there. Testing in smaller chunks. And yeah, let's get going. So today's problem is called Jump Game. And the deal is, given an array of non-negative integers, you are initially positioned at the first index of the array. Each element in the array represents your maximum jump length at that position. Determine if you're able to reach the last index. Okay, so I guess we can choose to jump or not jump. Each element array represents your maximum jump length at that position. So we don't have to necessarily jump that far. Okay, interesting. So in this one, we jump one step from index 0 to 1. Hey, what's up, Vlad? Hope you're having a good one, Vlados. I just changed my wallpaper from the eagle eyes. It was freaking me out. Now I've got some like sci-fi warship. It's pretty cool. Oh yeah. All right, so yeah, we this is a good example of us not jumping the full distance. So we jump from this index to this index. Then we can do 3 steps to the last index. All right, there's like, I think I might have just got swatted. Yeah, let me, hold on, there's like something going on. It's crazy. There are like 5 police cars outside my house. I think that's 7. Hey, good morning. Sorry, I had to step away there. There's something weird going on at my house. RMS. Alright, let's see. Am I still on here? Yeah, I guess it's somebody's birthday or something, and maybe they're a police officer. It just had like 8 police drive through my cul-de-sac, blasting their sirens. Okay, where were we? And hey, yeah, welcome, Will. What's up? Vlad, you gotta check out Will's stream too. Let's see here. Okay, hopefully you guys aren't hearing this, because now that's a fire truck in my little tiny cul-de-sac. Oh my gosh. Alright, sorry about the distractions. It's very strange in my neighborhood right now. Okay. So, where are we at? Oh, now the dogs are barking. Alright, I think everybody's calmed down. Is the music too loud, by the way? Oh wow, this is incredible. It's another fire truck or police officer. And it's literally like right here, right downstairs. Wow. Okay. All right, glad to hear about the music. Okay, hopefully, yeah, hopefully the sirens are done for a little bit. All right, so given an array of non-negative numbers, we are initially positioned at the first index of the array. Each element in the array represents the maximum jump length. So we have to jump at least somewhere, but we have to decide where to jump. So if we start at the 2, we could jump 2, but you can see that we're better off by jumping here. So it kind of makes me instantly think of like kind of running sum type stuff. So we don't actually have to figure out the best path, we just have to figure out that a path exists. And then we return a true or false. So here, if we were being greedy, we could start here and say, let's check 1. All right, that's going to give us a total potential distance of 4. Or we could do this, which will, yeah, that would be 4. This one would give us a total potential of 2 plus 1, which is 3. So we can see that this one gives us better potential. So it's kind of tempting to go with that and to just be greedy about it and say, okay, which one has the most potential here? Well, it's got this one, so let's go down that path. But that ends up doing a lot of extra work. So if we did, because the 3 could potentially get this 1 and this 1 and this 4. And we don't really care what the path is, just as long as it gets us through it. So I think greedy would probably work out in this case. Is that true? Yeah, I think greedy will work. I know greedy solutions are kind of controversial in general because they're kind of hard to prove and you can coincidentally get them right very easily. So they're dangerous. But if I go here and then choose to focus on the one that's bigger, assuming the bigger one gets us the other options we want, I think that would be good. For some reason, I keep thinking about starting at the end and going backwards, though. So if I know I need to get to this index, then I count it down. I don't know. I kind of like the greedy thing. I do feel like there's something coming from the back, but I don't know. I'm not seeing a clear path there, so I think I'm just going to start here. So let's look at this one. This one does not have a good path, so this is a good one to look at. So here, if I look at my 3 options, I can see that this one's the biggest, even taking into account the distance that I've traveled with this, so I have to be careful about that. So I have to add like 1 distance from this and 2 here, so the total distance is 3. Here this is 2 plus 1, so also 3. So these guys have the same total distance. Now 3, this is going to be 2 hops plus the 1 here, so it's also 3. So in this case, all destinations end up having the same. So it doesn't matter which one of these I go to, which is fine. So that sticks with my kind of theory that I could just take the greatest. And here's the last stop, which is also 3. So all these have 3 as the max size, because I'm doing 3 hops to get there, and then I add 0. And from this point, no matter which of those paths I take, I either go 2 from here, which, yeah, so all paths get stuck at the 0. So we cannot continue here, so we never make it past. So I think this is going to work. Alright, to put this into code speak though, I'm going to start at the first item, and then I'll look at all of my options, which is scary to me, because if I had like a big number here, like imagine a really big array and this was like 100, I'd have to like look at 100 indexes to find the biggest. Is that so bad? So I guess the worst case scenario there would be something like this. It's got like 100 and 98, 97. So I would do all the math for all these items. And then I guess in this case it's another case where it doesn't matter which one I choose because they all add up to the same. So maybe it would have to be something more like this. So I would still have to look at all those potential children. Then I get to this item, I would still look at all those potential children. This item I would still look at all. Yeah, so that's pretty gross. So this is an n-squared algorithm. My greedy solution is not good enough. Better to figure it out now. It's not going to be fast enough. Alright, so let's think about working backwards. So I said my target equals, with this example, 1, 2, 3, 4, 5. We're trying to get to index 5. Index should wrap solution as 0. It's the only solution you don't like. Should I wrap solution to 0 and the only solution you don't like? I'm not sure what to make of that. I'm not sure what you mean. Hopefully I didn't just do a big gulp on the mic. Oh, I could possibly skip it to 0, because yeah, 0 is dead ends, right? Yeah, that's a good point. I don't want to ever consider... I don't want to consider that. So working backwards, yeah, maybe that's something I have to watch out for. Now my headphones are dying. Happy Saturday. At least the sirens have stopped. I need my chill tunes. This is royalty-free music on Spotify, by the way. There we go. Alright, back in the zone. So if our target index is actually 4, not the length of the array, so it's length minus 1. Our current index will equal 4, because we're starting here. So somehow I have to find some combination of numbers that add up to 4. So that's the target, and we're at index 4. So what does this number mean for us? It's interesting because for this number I only need this to just be a 1. So I think I have to, and this one has to just be a 2. This one has to be at least a 3, or else it has to get us past these other points. So I think I have to take the current index into account here. Trying to take the first path, which gets you to some greater than the length. Yeah, that works. I just was worried about it being n squared. Like, so if you do a greedy solution and you have an array that looks like this, imagine 100, and then I don't know, 200, 300, 400, 500, and it's just a really big array. Then you look at your first item, you have to add and see which one is going to be the biggest number. So 100 plus 200, 100 plus 300, 100 plus 400. And you're going to have to go and you're going to have to check all of these items up to, 100, which is a lot. And then, let's say this one's the winner, you would have to go and do the same calculation for all of these to figure out which one's the biggest. So unless you do some sort of caching, and then again, assuming this one's the biggest, you have to do all that work again. So I just wasn't sure how to really do that in an efficient way. So worst case scenario, if it's ascending like this, it's an n squared solution, which I'm guessing is not going to pass the test. So our index is 0, and what I'm saying here is that this one has to at least have a hop of 1. And this one, if this was 0, would have to have a 2. So I think there's a correlation here between the index we're trying to get to and also the number of backward steps we've taken. So I'm going to keep steps at 0. And what I'm thinking here is basically, whether recursively or not, I'll start here and say, hey, does this number, so it's like if my current index or if my nums at the current index, I think this is it. I think this is going to work. So if this number is greater than our target plus the steps we've taken. Did I do that right? So if the item at this array 4, yeah man, definitely gonna do some smaller chunk testing here. So does this item greater than our target plus whatever step we're on, call it step. So in this case, 4 is greater than, but I don't need target plus steps. I need a 1 here. I need to check if this number is greater than 1. So in this case, it's going to be the target index minus my index. Is that right? So I'm saying, is this number right here greater than 0? Yes. So then what do I do? Then I know as long as you can get to here, that we're good. Okay? So then, that kind of shortens the problem to this. And I think we could just ask that question again. Is this number big enough? Well, I'm trying to get to the last index, so I think I'm off by 1 here. So my target index is 4. And our current index really should be 3. Because we are really asking about this guy. We don't care about this item. Because if we're here, we already won. So this could be a 0 and we still win, I believe. Okay. I think this might be really easy, which makes me think I'm probably doing something wrong. Okay. So if I'm here, is the number at my index, which is 1, greater than my target index of 4 minus 3? It's equal. And that's okay. So I say yes, this one was good. So if we get there, we're good. So then I can hop back any number of steps less than that 1 to figure out to keep it marching backwards, basically. So let me put this in there. So the chick can only walk backwards this distance. So that's the most we can travel. So we'll have to keep track of that. All right. So let me get this stuff down here. I was just going to convert it to code. Target index equals nums.length minus 1. The step, which is the current number of steps we've taken, which I guess I didn't actually use that, did I? Let index equals target index minus 1. So it starts out at 4 for the target index, and then we start out at 3 for our current index. We're going to do a while loop. I haven't figured out what that is yet. If our number at index, in this case was a 1, is greater than our target index of 4 minus our index of 3. So is 1 greater than 4 minus 3 greater than or equal to? Yes. So we can continue. So I have to figure out what the while loop here, and I think what it is basically we can do some sort of like max steps, and that will be equal to, what is that equal to? Nums at the target index to start. So this is equal to, in this case, it's at this index. Ooh, hey, what's up, Abdul? Alright, I'm not doing a very good job of what I'm explaining here, which probably means I'm doing a poor job of understanding and doing it. But basically I'm trying to work backwards. So I've got my target index here. So what I wanted to do is basically figure out if any of the people before me are able to get me to here, assuming it can go on. Oh, it's all good. Hope you're having a good one. So I think ultimately what happens is we'll figure out, is this enough to get to the last index? In this case, yeah, it is the last index, so it's good. So that's true. So in that case, is there any way for me to get to here? So it shortens the problem and kind of says, okay, of these 3, will any of you get me to here? Yeah, okay. So then here, is there any way to get me from, get me to here? So is it enough to just walk backwards? Minus, minus. All right, let's walk through this. I feel like this is close, but I'm definitely missing something. So our target index equals 4. Our current index equals 3. I took this max step variable, but I don't think I'm not using it currently. And really, yeah, it shouldn't be, that number doesn't make sense. So these are the 2 numbers I'm working with. Index is greater than 0, so we're good there. I'm looking at this example. If the numbers at target index minus 1, so if the number here is greater than or equal to 4 minus 3, yes. I shouldn't do a continue here. What should I do here? I feel like I need to do something else here. Like I need to... Oh, I changed my target index. Okay, awesome. Okay. So my target index was here. This should be not a constant. So basically I figured out at this point that this item is enough to get me to here. So I can set my target index equal to my current index. Okay, so now we just set target index to 3. All right, now we reduce index by 1, so now we're looking at 0, 1, 2. We say while index is greater than, should probably be greater than or equal to 0. It is. If the number at 2, 1, is greater than target index minus index 2, then target index equals index. Okay. Then index equals 2. Okay. Come back around, and 1 is greater than 0. Is this item bigger than 2 minus 1, 1? Yeah. 3 is bigger than that. So we shrink the target index down, and then index minus minus. Okay. Then, same thing. If index is greater than or equal to 0, check. If number at this index, 2, is greater than or equal to 1 minus 0, yep. Target index equals the index. Okay, there we go. So then I think if at the end of that, target index equals 0, then I think we might be good. But I want to test this failure case, the non-happy path. But hopefully this is it. All right, so our target index equals 4. Our starting index equals 3. Oh, okay, this is a weird one. All right, so let's see how this goes. While index is greater than 0, check. If the number at index, which is this one, is greater than target index 4 minus 3, it's not. So 0 is not greater than, how would that behave if you have, I'll try that in a second here. I'll try that one next. So it's not. So this is the first time we've had a case where we can't continue here. So we're not going to change the target index. And then we reduce our index still. So now we have to find a jump of at least 2. So index is still greater than 0. If the numbers at the index, which is 2, so we're looking at this 1, is greater than target index minus index, which is 2. It's not, so we continue. Index minus minus. Now you can see we need to make a jump of 3, but 2 is not greater than 3, so that goes down. 3 is not greater than 4, so this is a false. So I think that worked. This might be a good solution. So let me try this, Vlad. Vlado, so just to make sure, you're talking about that, right? So in this case, the index is 0, 1, 2, 7. And the current index is 6. Okay, so we look at the last item. Oh, no, sorry. We look at this item. So index is greater than 0, yes. Index at 6 greater than target index minus index 1, which is 0. So no, it's not. So we reduce our index. Is this item greater than 7 minus 2? Nope. Reduce our index. Is this number 3 greater than or equal to target index minus index? Is 3 greater than or equal to 3? Yes, it is. So we change our target index to 4. Okay. So as long as we get here, then we should be able to win. We reduce our index. So now we're looking at this item. Is 1 greater than or equal to 4 minus 3? Yes. Okay, so we set this and reduce this. And then now we're looking at index 2. So is index 2, so is 1 greater than or equal to 3 minus 2? Yes. So we set the 2 down and reduce the index. Now we have 0. So is 0, this is what you kind of mentioned earlier, is we might be able to just skip zeros. Is 0 greater than or equal to 2 minus 1? No, it's not. So we come in here, we change the index, we did not change the target index. And now we say, is 2 greater than or equal to 2 minus 0? And it is. So we reduce target index to 0, and we win. And so that tells me if I hop, that there is a way through this, so I could hop 2, hop 1, and hop to the end. So I think this is it. So much for testing in small chunks, huh? This is a short solution though. So we got the right answer there. Let's check this one. Okay. Let's try it. Oh my gosh. Look at that. All right, first time. Okay, looks like everybody solved it kind of similar to this. Better than 62%, I'll take it. Okay, that was a cool problem. All right. I'm glad with how that turned out. All right, now usually on Saturdays we've been doing a longer stream, but I told Outlaw that I wanted to play video games instead, so we're gonna do that. But tomorrow I'm looking at coming back with Super Good Dave and looking at some QIT stuff if you're interested, especially Vlados. Yeah, I don't know if we're gonna stream that or just hang out, whatever. But cool. All right, happy to see that. Let's see here. I wanted to see how far in the contest. I just wanted to see all these beautiful check boxes right here. Reminds me of passing tests. So checks, 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 and checks. I do kind of want to look at the results of that one again, just because I don't know. I thought working backwards was kind of weird. I expected most people to kind of try and go forward. So let me see if I just look at a sample solution here. I'm having trouble clicking on it. Oh my gosh. Oh, mathematics, that's interesting. So it's kind of a, this is kind of the solution we talked about initially, isn't it? Where we start at 0, so they're working up in this case. If the maximum, which is the first item, is less than I, return false. Otherwise they get the maximum. Oh, okay, so I guess the kind of question they're asking is basically is whatever number we've seen, oh that's slick, is whatever number we're looking at enough to get us to our current index? And if it's not, then we return false. So to like look at the sample, let's see, let's go back to the problem here. So that top solution, So it was kind of greedy, but they didn't have to check all the ones. So that was slick. So what they did is basically they said, let's start with 2. Is 2 enough to get us to index 1? Yes. Okay. Cool. Now also, what's my max? Max is now 3. Plus 1, which is 4. So now our max is 4. So hey, is 4 enough to get us here? Yep. Is 4 enough to get us here? Yep. Is 4 enough to get up here? Us here? Yep. Done. So to look at the failure case, they said start here with the max of 3. Is 3 enough to get to 1? Yep. Is 3 enough to get to 2? Yes. Is 3 enough to get to 4? Yes. Is 3, sorry, that was 3. Is 3 enough to get to index 3? Yes. But is 3 enough to get to index 4? No. So it's a fail. And 3 was the max. So, yeah. So that was slick. Okay. I'm happy with this, though. I definitely like that other answer of kind of counting up better. It's just more readable. This is weird. But yeah, that's nice. So 3 is enough to get to 1. The max stays at 3 because it's 3 plus 0, 2 plus 1, 1 plus 2 for the indexes. So yeah, okay. That's cool. Okay, well good. I'm happy with that. And looking forward to solving tomorrow's. Whenever I have a good day, I always want to like go on and do the next day, but it's not unlocked just yet. So we got 5 more days of this, and then freedom. Can work on whatever problem I want. Yay. All right, hope you guys have a good